We look at example number 1 as per your handout. A pre-stressed concrete beam of section 250 times 300 mm and effective span of 4.5 meter, as in the length is 4.5, is required to support an imposed load of 30 kilonewton per meter. Find the magnitude of minimum pre-stress force required when the eccentricity is 0 and negative 80 mm. For the first question, dia minta when eccentricity is 0. And for the second question, dia minta when eccentricity is negative 80 mm. If you watch the YouTube video this morning, this is the formula that we have. P is equal to M max divide with Z over A and minus with E. Ini adalah memang the general formula for the pre-stressed concrete. Sebenarnya banyak lagi formula lain. Okay, it's just that this one adalah untuk yang load dia hanyalah UDL, macam tu je. Just a simple pre-stress force. First kita nak dapatkan Mmax because we need to fit in our formula. Mmax is WL square over 8. W we have here, kita just ada the imposed load itself which is 30 meter. Darab dengan the length which is 4.5. Just divide with 8. You will get the value. My answer is 75.938 kilonewton meter. Then we have the value. Apa lagi kita akan cari? Z. Z is BD square over 6 because our cross section of beam ni just a simple rectangular. Kalau T section, you have a different type. So calculation of Z is different. And you tak boleh pakai lah formula BD square over 6 ni je. B is 250, so it becomes 0.25 meter. And D is 300 millimeters, 0.3 meter. My answer is 0.004 lah. And A is B darab D lah. You will get 0.075. Kita dah ada semua value eccentricity given. So masukkan je dalam you punya formula. Ni meter kosong. For our question number 1 ni, eccentricity dia 0, so you just minus 0 je lah. Then boleh kira. My answer is 1423.83738 kilonewton. Because ini kita pangkah hingga 1 ni hilang terus. Meter ni pun pangkah. So that's why kita dapat only kilonewton. And we need to do number 2. Yang lain-lain dia value dia sama je. The difference is the eccentricity itself. So kita just tukar on that part sahaja. When the eccentricity is 0 and negative 80 mm. Which means that 80 mm negative tu the tendon ataupun the pre-stress bar tu dia letak 80 mm below centroid, di bawah centroid. That's why negative. So negative ni jangan buang lah, but we need to convert it into meter. Negative 80 mm dia jadi negative 0.08. 569.535 kilonewton. So, you boleh tengok compare between these two kalau ada eccentricity dengan tak ada eccentricity. Bila you letak tendon tu below the centroid, meaning it is with eccentricity, it means that dia the pre-stress force yang you required untuk pull the tendon tu untuk dapatkan dia punya pre-stressing power dia lebih rendah daripada bila you letak the tendon to be at the centroid. You tak perlukan too much force untuk tarik the tendon. Then we move to example number 2. A rectangular beam 300 by 500 mm. 300, kalau beam, dia punya breadth mesti lagi rendah daripada height dia. Kalau dia kata 300 by 500 ke, 500 by 300 ke, you should know which side. Letakkan 500 jadi breadth. 500 tu mesti height. Is pre-stressed by means of 14 mm diameter high tensile tendons. For 14 mm diameter, located 100 mm from the soffit of the beam. So soffit ni kat bawah. So dia located 100 mm around here lah. Size dia 14 mm. What is the maximum bending moment that can be applied to the beam section without the causing tension at the soffit of the beam? So the question minta you cari max. Dia nakkan maximum bending moment. Okay, saya cari Z dululah. V kita is 0.3 meter times with 0.5 meter power of 2 divided with 6. It is 0.013. Then value of A 0.3 meter darab dengan 0.5 meter. 0.15 meter square. So sekarang soalan ni nak max. Kita boleh cari value of P, which is the minimum pre-stressing force tu. Nak cari P, kita nak yang kena pre-stress force ni adalah the tendons, adalah the reinforcement. Konkret tu dia tak kena pre-stress pun. And dalam soalan ni dia bagi effective stress, which is this one. Dari effective stress ni, you nak cari berapa minimum pre-stressing force. Kita ada formula of stress equal to force divide with area. And right now, what we are trying to find is the value of the force pre-stress. Sebab kita nakkan pre-stressing force which is the P, which is F lah here. Kalau dalam formula stress ni. Then F is equal to stress darab dengan A. So stress kita dah ada, which is 700 Newton over millimeter square. However, kita tak ada value of A. And A here, kita mesti ingat, this is area of the reinforcement, the tendon. Bukan area konkret. Sebab yang kena pre-stress tu adalah tendon. Kita kira area of the tendon. And kita tahu tendon ni ataupun bar ataupun main reinforcement whatever, the formula is pi r square sebab dia bulat lah. Tak ada tendon 4 segi Pi. Diameter dia 14 mm, so kita bagi 2 sebab I best kira pakai radius lah. Kalau you pakai pi d square over 4 pun boleh. Kita kena darab 4. Because of kita ada 4 numbers of 14 diameter. So darab dengan 4. 615.752. This value you boleh masukkan dalam nak dapatkan F dekat sini. The force. I punya jawapan 431,026.4 Newton. Kita tukar dia into kilonewton. 431.026 lah kilonewton. Okay, so itu adalah kita punya minimum pre-stressing force. So kita boleh masukkan value F kita ni ganti dalam P. Okay, sebab dia adalah force. 026 kilonewton. Kita cari Mx. Z is 0.13 meter cube. And the eccentricity here, dia kata 100 mm from the soffit of the beam. So eccentricity bukan 100. Centroid dia kat sini. Centroid of the beam. Since the height of this beam is 500, so kalau you kira dia punya centroid daripada bawah dia adalah 250. So you nak dapatkan distance between centroid ni sampai ke centroid main reinforcement. So what you do is just minus 252 minus dengan 100. So that is the eccentricity. then you will get 150. E dekat sini adalah 150 mm. 500 mm bahagi 2 tolak 100 mm. So 150 mm. Ini adalah dalam milimeter. So apa-apa bila kita kira, kita akan kira dalam meter. Saya terus tukar kat sini 0.15 meter. Then kita boleh dapat value of Mmax. Ini negatif jangan lupa sebab dia below centroid. So kalau below negatif kena dengan negatif, so dia akan tambah lah. Dia bukan jadi tolak. So my answer is 102.009 kilonewton meter. Okay, siap example number 2. Then we go to example number 3. Nampak memang dia bagi 350 times 150. So you tahu the logic is it should be the B adalah 150 and here is 350, the height. So ini dia punya length and support live load. The straight tandem provide eccentricity. Calculate the minimum pre-stress force necessary for no tension under live load at mid-span. So I nak tanya jawapan. I need the value of Mmax. Sebab dalam soalan ni, apa yang dia minta minimum pre-stress force. You tahu nampak je force, it should be P. Abdul Hakim. 46.875 betul. Okay, thank you. Alif value Z 0.003. Okay, betul. Thank you. So sebenarnya dapat 0.0030625 Tapi sebab kita ambil 3 decimal places je, so it is 0.003. I cakap Syahira tadi. 0.053 betul. So Uyun berapa P?
0.586.
Tak apa, I do it. So Mmax is 46. Kita check balik 875 kilonewton per meter. Z is 0.003 meter cube. Dia kata eccentricity 80 mm below the centroid means that negative 0.08 meter. Okay, bagi 1000. Then my calculation I dapat 343.146 kilonewton. Tengok the units lah sebab kat sini kita pakai semua meter lah. So kita itu meter. Okay. So that will be all. If no question you're going to ask, I'm going to end the class here. Thank you so much everyone and have a nice day.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.